Hello everyone, I am Saranya, Assistant Professor in the Department of Graphics and Creative Design of Dr. S.Saranya College of Arts and Science. Now we are going to see about the modeling and animation using Maya. In that we are going to see NURBS techniques. What is meant by NURBS techniques? How we can modeling with the NURBS techniques? Way to make NURBS. First one, NURBS. What is meant by NURBS? Non-uniform relational B-spline lines are the mathematical representation for creating smooth curves and surfaces. The control points, weights, degree and knots are the fundamental parameters in the NURBS modeling. Real-time example, using Autodesk Maya, you can create a NURBS curves by defining control points and adjusting their weights to shape a 3D curves. This is a normal polygon and we are creating using the NURBS. NURBS define the best texture effects for the particular object. Next is the lofting method. Lofting involves creating a smooth surface by interpolating between the cross-sectional profiles. Cross-sectional profiles guide the lofting algorithm to generate a continuous surface. Real-time example, the lofting can be demonstrated by creating two different profiles and using the loft component command to generate a smooth surface between them. In that you can see the lofting method of a conic shape. In cone shape, how we can use the lofting method. Next one is revolved surface. Revolving a curve around an axis create a surface. The axis of revolution and the curve shapes determine the resulting surface. Real-time example, you can draw a 2D profile and revolve it around an axis to quickly create a 3D object like a vase or bottle. Here we use the revolved surface for designing a bottle. Extruder surface. Extruding a curve along a path create a surface. The length and direction of extrusion determine the surface shapes. Next is real-time example. In Blender, you can extrude a NURBS curve along its path to create a 3D surface, such as for creating architectural elements. This extruder path. Next one is planar surface. A planar surface are a flat and defined by a closed boundaries curve, useful for creating flat surface like panels or walls. Real-time example, in SolidWorks, drawing a closed 2D sketch and extruding it in the z-axis creates a planar surface. Next one, beveled surface. The beveling involving adding a fillet or chamfer to the edge of the surface. It enhances the visual appeal and realism of the model. You can apply a bevel modifier to the NURBS surface, creating rounded edges for the most polished look. Here you can see the rounded edges for the most polished look. Next is boundary surface. A boundary surface is created by defining 4 boundary curves. This is useful for creating complex curved surface with precise control. Real-time example, in CATIA, you can create a boundary surface by selecting 4 curves that defines the boundaries of the desired surface. You can see the boundary surface for desired surface like in the object. The beveled surface. The beveling involves adding a fillet or chamfer to the edge of the surface. It enhances the visual appeal and realism of the model. Mostly the bevel and enhanced effects will be used in 3D effects. Using the 3D Max, you can apply a bevel modifier to a NURBS surface, creating a rounded edge for the more polished look. In the example, you can see the extruded area, beveled area, cop area. The cop area is nothing but is the area which is the center. The beveled area is nothing but it's in between the extrude area and the cop area. That is, mostly it is come under the flat surface. The next is extruded area. That is how thickness of the objects will be come under the extruded area. Next one, boundary surface. A boundary surface is created by defining four boundary curves. This is useful for creating complex curved surface with precise control. Real-time example, in CATIA, you can create a boundary surface by selecting four curves that define the boundaries of the desired surface. In the example, you can see the boundary surface of one object. It is rotated in the x and x, y and z axis. Three axes it is rotated, and the visibility of the object will be viewed like this. Thank you.